Hello everyone. Today let's solve the problem number 9.1 decode ways. Right. So what the question states here, we are given a string s. You can clearly see here we are given a string s containing only digits from 1 to 9. You can clearly see we are given a string s. Within the string s it contains only numbers from 1 to 9 and we need to determine how many ways we can decode it in the alphabetical representation. Sorry. So we need to determine how many ways we can decode into an alphabetical representation, right? So that's what we need to decode. So what is the requirement or the condition here where 1 maps to a, 2 maps to this one? Just give me a second here. So here 1 maps to alphabet a, 2 maps to alphabet b, 3 maps to alphabet c. Like that it will go until the last one. This one 26, we have 26 characters, right? 26 maps to alphabet z or z. So this is one thing. A number can be decoded either as a single digit or 2 digit. Either we can decode it this one number as this one. A number can be decoded either as a single digit or the 2 digit. So we can either decode in single digit or the 2 digits. So here, for example, let me consider 2 here. Suppose if they have given 2 within the strings, then this will be b, right? This is for the single digit. So suppose if we consider here 12, if there is 12, right, then we can directly consider this one l, right? In this case l is nothing but 12. So a number can be either single digit, this one, a number can be decoded either as a single digit or a 2 digit. You can clearly see here, right? So this is one thing. The third condition and the final condition here is a string with leading zeros like 06 is invalid and we should return 0 in that case. Suppose if we are given like this 06, so anything that is starting from the leading 0, then we have to return 0. This is considered as invalid if it starts from the 0. So leading 0 is always considered, the number with the leading 0 or the leading 0 is always considered as the invalid, and in that case we have to return 0. That's what they have given in the question. So I hope the question is completely clear. Let's come to the example they have given here. 12, there are two ways they have given. 12 can be decoded as AB. Yeah, we can decode this one as A and B, right? One is A, 2, we'll consider this one B. So it can be AB. 1 is nothing but A, 2 is nothing but B. It can be AB, or we can directly consider 12 as L. That is also possible. So there are two ways. So to that we have to display or we have to return the number of ways. That itself we have to return, right? So here the number of ways of decoding the digit is 2. So here finally we are returning 2. Let's come to the example 2 here. So just give me a second here. In example 2, we are considering 2 to 6. So they have given here 3 ways. 2 to 6 could be decoded as this one BZ. Here you can clearly see B and Z. 2 and 2 6 we can consider, or 22 and 6 VF we can consider, or BBF 2 space 2 space means this is B, this is B, and this is F. This is also possible. So there are 3 ways of decoding this digit 2 to 6, and same goes with example 3 as well. 06, there are 0 ways because here we have leading 0. You can clearly see here we have leading or the trailing 0, which has to be in this case we have to return 0. Any number which has the leading 0 or the trailing 0 is considered as 0 in this case. I hope the question with the examples that we have discussed, I hope the question is completely clear. So let's see how can we solve the problem, right? Let's discuss the approach first, followed by this one edge cases one by one, and then finally write the code and discuss the complexities of the code that we have written. Initially, as usual, let's discuss the approach. So here let's discuss the approach step by step. The first thing you have to remember here is we will be going with the dynamic programming approach here. So we'll be making use of the dynamic programming here. So the first example what they have given in the question, that example, the second example I have considered here, sorry, not the first example, second example. S equals 2 to 6 they have given, right? The same example I have considered here. So first what we will do, we will go with the initialization, right? So let's see, we have to get the output 3 here in this case, right? So first let's go with the initialization. What we have to do, we will create the DP array of length, this one, string length plus 1 here in this case. So why it is length of length plus 1, we can just consider s dot length here, right? So this is just for the easy computation or easy calculation. We'll be going with the s dot length plus 1. So here we'll be creating the DP array of length plus 1, and we will represent the here DP of I, nothing but it represents the number of ways to decode the substrings. So we can just write here 0, it starts from 0, and we can just give here to 0 to I minus 1. This is length. So we are considering I minus 1 as it is 0 index. So 0 to I minus 1. This iterated value of the DP represents the number of ways to decode the substring. I hope this is clear. Now let's come to the base case or the first step. Always remember, we will first set DP of 0 to 1 here. Initially what we will do, we will set the DP of 0 to 1. This is the base case, and S of 0 is 0 in this case, right? DP of 0 is 1, we are setting the base case, and S of 0 is 0, we will return 0 in this case. These two these two steps are important. Here DP of 0 is nothing but 1, we are setting DP of 0 to 1 right here. So just give me a second here. Yeah, we are setting DP of 0 to 1, nothing but the base case. If S of 0 is 0, then we have to return 0 immediately, as 0 is not a valid character. This one is 0, 6, we saw this one in the trailing, this one in one of the examples, right? So third example I think. So 0, we return 0 as output because it starts from the 0. So leading 0, if any number has leading 0, or if we have 0 at the beginning, we have to return 0 in this case. So this is first case, base case, we are setting DP of 0 to 1, and this is second case. If 0, if we have the leading 0, we will directly return 0. I hope this is clear. So let's move on with the next step. Let's see the step-by-step execution for this one, number 2 to 6. So or this one here, right? So first we will initialize the DP array to 1 1 0 0. So this is for, so this is of the length 3, you can clearly see. So we are going with s dot length plus 1 every time. So we have 4 elements in the array. So don't get confused here. So this will be initially what we will do. We will go with 1 1 and 0 and 0, right? So this is the initialization for 2 to 6. So in the next step what we will do, we are processing s of 1, nothing but 2. Here 2 to 6 we have, right? 2 to 6 we have. We will process first 2 here, right? S of 1 equals 2 in this case. S of 1 equals 2 here. 2 is valid in this case, right? Because we have 2 here, right? For 2, what we will do, DP of 2 equals DP of 2 plus DP of 1. This formula will be going with. So DP of 2 here is this one, DP of 0, DP of 1, DP of 2, DP of 3. This one, DP of 2 is 0 here in this case. DP of 2 equals 0 plus DP of 1, here you can see 1. Here 0 plus 1 is 1 here in this case, right? So next we will go with 2 2. Another 2 we will add. First this is for only 2. Next we are going with 2 and 2, right? 2 digit is valid because we are not going with a 3 digit. So we are going with the 2 digits. 2 digit is valid accordingly to what we have discussed earlier. So this will be DP of 2 equals DP of 2 plus DP of 0. DP of 2 here we have from the previous step, the DP of 2 that we got here is 1, right? DP of 2 equals 1 plus DP of 0 is also 1 here, you can clearly see, right? Sorry, not this one. This is DP of 0. This one, second one. DP of 0 we have to consider, the first one itself. Sorry. 1 plus 1 here is nothing but 2 in this case. So now we got DP of 2, we got 2. So we are updating the DP array. Initially what we had here, 1 1 0 0. This is the initialization part. Now we are updating the DP array. In the case of DP of 2, this is DP of 0, DP of 1. So we are updating the DP of 2 by 2 with 2, right? This will be DP of 2 and this will be DP of 3 here finally. So this will be DP of 2. So we are updating this one by 2. I hope this is clear. So next step, let's move on with the third step here. S of 2, we are initializing this one to 6 here in this case. So we can't go with 2 to 6 in the third step. In the previous step itself, if I come here, 2 to 6 we cannot consider. First we considered 2 to, second we consider, first we considered 1 here, second we considered 2 to. 2 to 6 we cannot consider. We can consider either only one character or two characters at a time at one step. So we haven't considered 2 to 6 directly here. So don't get confused here. Next, we have to process S of 2 equals 6 and we have the DP array 1, 1, 2 and 0, right? From the previous step, we have the DP array 1, 1, 2 and 0. We know this one. So now only 6 here we are considering. DP of 3 equals DP of 3 plus DP of 2. This is the formula. And DP of 3 here, 0, 1, 2 and this one will be 3. DP of 3 is nothing but 0 here. DP of 3 equals 0 plus DP of 2 is 2. 0 plus 2 here, it will be nothing but 2 here. I have already written this one. We got 2 here. So next what we will consider 2 6, 2 digits at a time. So 2 6 we didn't consider, right? 2 2 we considered. 2 6 we didn't consider. This is one of the thing we have to consider. 2 and 6 we have to consider. In this case, DP of 3 equals DP of 3 plus DP of 1. DP of 3 we have from the previous step we have DP of 3 2, right? 2 plus DP of 1, here we have 1. 2 plus 1 here in this case. 2 plus 1 will be 3. So now what we will do, we have to update the DP array, right? Here we have 1, sorry, I'll just come here. We have 1, 1. From previous step we got this 2 and from this step we got 3, right? DP of 3. We are updating the DP of 3 by 3. Initially it was 0. Now we have updated this one by 3. Now we have 1, 1, 2 and 3, right? So final answer DP of 3 that we got here is 3. So this one we will return basically 2 plus 1 equals 3 we got here, right? 3. So this one here we will return DP of 3 equals 3 in this case. DP of 3 will be 3 in this case. So the output that we should get here is also same thing. DP of this one is equal to 2 to 6. Output they have given 3 in the question and the output that we got here is also 3. Here you can clearly see. Just give me a second here. Yeah, 3. So the approach works absolutely correct in this case. I hope the approach is completely clear. This is the approach that we will be going with. So next, let's go with the individual edge cases. I mean, let's discuss edge cases one by one. So the first edge case will be going with 0, 6 when we have the leading 0, right? This one we know from the question that if we have the leading 0, we will directly return 0. In this case, it will be 0. Here in this case, we have considered 1, 0, right? For 1, 0, output will be 1 here. Why the output will be 1 here? Because we have this one 10, we can directly consider 10 as j, right? But 0 alone is invalid. We know this one. 0 alone is invalid. So we cannot consider two characters at a time. So we'll go with j directly. So output will be 1 in this case. So 11106 I have considered here. This will be 2. 0 from here, this one will be invalid, and for the 111 if we consider, there are 2 ways, right? So the overall output is 2. These are the edge cases that we need to consider, right? I hope this is completely clear. So 06 is invalid because we have leading 0, right? This one is leading 0. So we will stop this one. We'll only consider 111. So output will be in this case 2. You can just try it out in the same way that I showed for the example, right? That I took the second example during the approach. You can just try it out in the same way. If you want to try it out for 1, 2 and 3, you can just try it out the same way. So these are the edge case that we need to consider. Now let's start writing the code. So let's start writing the code here. So first thing, we have already discussed about this. If the length of the string means if we don't have here string at all, if the length of the string is 0, and if s of 0, initial one is also 0, only 0, then what we will do, we will return 0. Initially we shouldn't have 0, leading 0 at all, right? So that is one condition. And length of the string is also, if it is 0, then in that case we will return 0. I'll just come here, s dot length, this is equals 0, or s of 0 equals 0. Then what we will do, we will return 0 in this case. I hope this is clear. So next what I'll do, let's initialize the dp array of length plus 1, means length of the s plus length of the string plus 1, and let's initialize or let's fill that one array with a 0. So we know this one, right? So we have already discussed this one multiple times here. New array, let's initialize this one with the length of the string plus 1 by, just for the easy computation here. So let's fill this one with 0 initially. This is fine. So dp of 0, let me initialize this one to 1, and dp of 1, what I'll do, let's we have done this one. dp of 1, initially if s of 0 is 0 within the strings, then what we will do, ternary operator I'm making use of, we will return 0 initially if s of 0 is 0. If s of 0 is not 0, then we have to return 1 in this case, right? Initially we are initializing with dp of 0 equals 1. So that's what we discussed in the approach, right? So this one also, we have created a dp array of length plus 1, length of the string plus 1. This one also we have discussed, and this one as well. So next what we had discussed, if you remember, so let's go with the iteration. Let's start with 2. So for let I equals to I less than or equal to length of the s. So let's increment the I here. So first step what we will do here means, let's extract the last 1 digit number. So we have to extract the last 1 digit number, right? So I'll just give here 1 digit. So this is just for the sake of variable naming. So it will be easier to understand if I give 1 digit here. So we are just extracting the 1 digit number. So I'm just taking it as here the variable name 1 digit, right? So I'll just give here in this case plus s of I minus 1. This is fine. So the next step here is, we are extracting the last 2 digit numbers. First we are going for the 2, and then we are going with the 2 digits. First we are going with the 1 digit, second we are going with the 2 digits. We cannot go more than 2 digits. Again, for the third digit what we will do, we will go for the 1 digit and again 2 digits. In that way we will go. We saw the same thing during the approach, right? Now we have extracted last 1 digit number. Next we will extract last 2 digit numbers. So I'll just give here last 2 digits equals plus s dot substring here I minus 2 comma I. This is fine. I hope this is clear. So simple if condition here, let's write. So if the last digit is valid, then we have to inherit the dp of I minus 1. Previous one we have to consider, right? So during the computation we saw the same thing. If the last digit is valid, suppose if we are calculating for dp of 3, so we have dp of 3 equals dp of 3 plus dp of 2 we have. So we have to inherit the last one from dp of 2, right? So that's what we were doing. If the last digit is valid, we have to inherit dp of I minus 1. So I can just write it in the same way. So here simple if condition I'll consider here. If 1 digit greater than or equal to 1, in this case iterated value of the dp equals dp of I equals dp of I plus previous one dp of I minus 1. dp of 3 equals dp of 3 plus dp of 2, right? So that's what we are doing here. So that itself I am just articulating that one in the form of code. So this one has to be I minus 1, sorry. Yeah. dp of I equals dp of I plus dp of I minus 1. I hope this is completely clear. Next step is if 2 digits is greater than 10. So if it is lesser than 10, then we can just go with a single this one single way, right? 0 to 9 we can consider. If the 2 digits is greater than or equal to 10, and I'll just consider here 2 digits less than or equal to 26, means between 10 to 26 we are considering, right? Means from 10 to 26 we are considering. So here what it should be, we will go with dp of I plus dp of I minus 2 in that case. So I'll just give here dp of I equals dp of I plus dp of I minus 2. I hope this is completely clear. Means if the last 2 digits form a valid number, right, then we have to inherit dp of I minus 2. So we already saw this one in the example during the approach. The second example that we considered, we already saw this one, right? If the last 2 digits form a valid number, then we have to just inherit dp of I minus 2. That's what we are doing here. That's what we are articulating this one in the form of code. The final step here is we have to return the number of ways to decode the full string. Means here I'll just come here, let's return the number of ways to decode the full string. Means here dp of length of the string, nothing but s dot length here, dp of s dot length. So I hope this is completely clear. So let me format this one once and let me hit the run button. So you can clearly see here all the sample test cases are getting passed here. You can clearly see, right? So let me hit the submit button. I hope this works. Let's see. Yeah, all the test cases are getting passed here. So the code that we have written works completely correct, right? So just give me a second here. Did I miss anything? All right. So yeah, let's discuss the complexities of the code that we have written. So the approach that we went with here is dynamic programming. We know this one, right? So what will be the overall time complexity here? The overall time complexity would be big O of n. Why it is big O of n? Because we are iterating through s once. You can clearly see here we are iterating through s only once, right? Means we are iterating through the string only once here. You can clearly see. So the time complexity would be big O of n. So what would be the space complexity here? The overall space complexity would be big O of n as well. Why? Because we are storing the results in the dp array. When when I say we are storing the results in the dp array, you can clearly see here we are storing this one in the dp array, right? So dp, we have created a new array of length plus 1. We are storing this one here also. You can clearly see we are storing the results in the dp array. The overall space complexity would be big O of n as well. So the time complexity and the space complexity of the code that we have written is big O of n. So I hope the code or the solution that we have written is completely clear. For now, this is it. Thanks for watching, guys.